All right, this is the last video of the unit circle. Unit circle, I believe this is part 5 now. So what we did last time is we drew these triangles and we took them out of the unit circle and we looked at the 30, 60, 90, 45, 45, 90, figured out what the coordinates in the first quadrant are. And I had said we're not going to do that regularly because there's a memorization trick. We're also not going to do that for the other quadrants. So I'm going to fill in those coordinates and I'm going to show you a little bit of a trick for memorizing them. So this is 1, 2, 3, 1, 2, 3. Every single denominator is 2, and every single numerator has a square root. However, the square root of 1 is 1. So I'm going to erase those. The square root of 1 is 1. I'm going to do that one more time off to the side. 1, 2, 3, 1, 2, 3. Every denominator is 2. Every numerator has a square root, but the square root of 1 is 1. So again, you won't see that written in. And then there's a comma because you have an x and a y. So those are the coordinates of the unit circle. And I'm gonna start with this one. So this is root 3 over 2 and 1/2. So when I go to the other quadrants, they're going to match up with this coordinate. So I'm going to go straight across, I'm going to go straight down, and I'm going to go straight over. So all of those coordinates are the same. You can see that the y values, like if you're going straight over, the y value is not going to change. If you go straight down, the x value doesn't change. If you go straight over, the y value doesn't change. Also, this was a 30, 60, 90 in that same triangle. This is also going to be 30 degrees, so it's the same triangle as well. That's not something you really think about. I'm just saying that because this is our first time seeing it. So all you have to do is take these coordinates, and then when you move into quadrant 2, think about what the signs are in quadrant 2. What is the x, positive or negative? What is the y, positive or negative? So in quadrant 2, you have a negative x and a positive y. So all you do is you make the x negative and you leave the y positive. But it's the same, it's still root 3 over 2 and 1/2. It's just that the x became negative. When you go to quadrant 3, think about what those signs would be. Quadrant 3, you have a negative x and a negative y. So you're using those same numbers, negative root 3 over 2, and then it'd be negative 1/2. And then finally, you move into quadrant 4 and think about what the signs are in quadrant 4. You have a positive x and a negative y. And so that's going to be root 3 over 2 and negative 1/2. Right? So negative and a positive in quadrant 2, both negative in quadrant 3, and then a positive x and a negative y in quadrant 4. Okay, so then I'm going to go to a new unit circle. This one was root 2 over 2. And I'm going to go straight across, straight down, and straight across. So this one is going to line up with all of these middle pieces. Those are all your 45, 45, 90 triangles. So all the side lengths are going to be the same. It's just the signs that are changing. So again, into quadrant 2, you have a negative x, negative root 2 over 2, and a positive y, root 2 over 2. Quadrant 3, they're both negative. So negative root 2 over 2, negative root 2 over 2. Quadrant 4, you have a positive x, root 2 over 2, and a negative y, negative root 2 over 2. And the very, very last set of coordinates was the 1/2 and √3/2. And these are going to line up with this one, and this one, right? Straight over, straight down, straight over. So all of these coordinates are going to have the same numbers, which is 1/2 and √3/2. In quadrant 2, you're going to have a negative x, so negative 1/2, and a positive y, √3/2. In quadrant 3, they're both going to be negative, so negative 1/2 and negative √3/2. And in quadrant 4, you have a positive x, which is 1/2, and a negative y, which is negative √3/2. And that gave you all the coordinates, right? Because we started with this one, we moved to this one, and then we ended with that top one. So that would fill in all the coordinates. And again, we just kind of use that idea that the triangles are the same so that we don't have to sit and derive every single one. All right, that's it.